Hello, everybody. Um, uh, Before starting with Aspen Plus, there is one important point that I didn't mention in the previous video that was mentioned in chapter 1 in the textbook Process Analysis and Simulation. Um, Oops, it's this book. Anyways, yeah, this book. So it was the something in the first chapter. The first chapter kind of covers the basic concepts of simulation and what the purpose, or why do we use the process simulators. And this is something that's easy to understand, and it's kind of easy to follow in this textbook. So I'm not gonna go into these details. We use process simulators for different reasons. We use it to get the solution to a process flow diagram that we don't have any or all the information about. You can use it to design some equipment like distillation columns, heat exchangers, to achieve a specific separation or specific heat transfer, or whatever the function of this unit. And there are other reasons for using the simulators. There are many types, as we mentioned before. The most famous is Aspen Plus and Aspen HYSYS. There is Pro2, there is KimCAD, there is SpeedUp. Anyway, so these are the commercial software that are used for academic purposes or for research purposes. There are other software that are used by the big licensing companies that are more powerful and have more kind of features that are more suitable for their applications. Um, anyway, so for the point that I want to discuss in this video is the what's covered in section 1.3, which is types of process simulators. So this is important for us to know because it kind of lets us know how the simulator works and how it deals with the system and how it solves it. And just to understand how it works, just remember how we do the material balance calculations manually, or as we did before using Microsoft Excel. When we do the solution, we first go with the degrees of freedom analysis to tell if the number of givens or the information that we have are enough to solve the system or not. And then we check the degrees of freedom of each unit so that we can tell what will be the strategy of solution, which unit is going to be the starting unit, and um, what is going to be the next, and so on. And we know from this if we are going to do any tiering, so that we can do what we call the iterative solution, so we can get the final solution in case of recycled streams or something like that. So this is the way we do the solution if we are gonna do it manually. And it's important for us to know how the software deals with it. So the software can do the solution using one of two techniques or strategies. The two strategies are called the sequential strategy and the simultaneous strategy. So these are the two main ways the software deals with the flow sheets that it solves. The sequential strategy is exactly what we mentioned in few seconds. Is how we do the solutions by hand. You start with one unit and then you go to the second. You solve it. You have more information that are given or considered as givens to the next unit, so that this unit is solvable. Then you go to the third and fourth and whatever until you finish the flow sheet. And in this case, is used by, or this strategy is used by Aspen HYSYS, for instance. So if you're solving a software or a process flow diagram or a process in Aspen HYSYS, you would notice that easily. You can see that the first unit is kind of blinking between yellow and I think it was red, and then when it's done it turns into green, and then the following unit starts to blink until it's solved, then the next unit starts to blink until it's solved. So you can tell at specific moment which unit is solving at that time. And this is totally fine and it's okay. But there is one problem is that or one of the problems with or the drawbacks of this strategy is that it's not easy to do recycling. So if you're recycling a stream, then you are having a stream that's coming from the like the next or the end of the flow sheet, and it's going into the beginning unit of the flow sheet. And this is not something that the sequential strategy understands easily. And that's why you, for instance, in Aspen HYSYS, you need to define that this is a recycle stream. It's not something that it understands by itself. So you have to connect the recycle stream with the stream that's gonna be mixed with, or the unit that's gonna be mixed with, and then you connect them with an R, which is a recycle stream. So you can tell it that this is a recycle to this place. And of course, as the recycle streams get more, the solution gets more and more complicated, and it might be very difficult to solve using this strategy. On the other hand, the simultaneous strategy does not depend on solving any unit by itself. Um, just to understand how it works, what we do in the simulator, you just click on a unit, a flash unit, or an absorber, stripper, whatever the unit that you're gonna pick, and you put it in your flow sheet. And you see that this is a tower in the flow sheet, but actually the software sees this tower as a set of equations of material balance, of energy balance, yeah, it's energy balance and equilibrium relations, and this is how the software deals with it. So this simultaneous strategy simply collects all the equations in the system from all the blocks or the units that we have in the system, and consider them as a set of equations that are gonna be solved simultaneously. It doesn't matter if they are 10, 100,000, whatever the number of equations that we have, but this is how it solves the equations. In this case, you don't have the issue of defining a recycle stream, because the stream is gonna be defined as a variable that's gonna appear in the final equation and in the first equation. So it doesn't matter. You don't have to do any more definition for the recycle streams. However, this strategy of solution has a drawback of kind of failing to converge in very big flow sheets. If you have a very big flow sheet, and then you have a huge number of equations, then it might be kind of difficult for the software to get a solution that satisfies all these equations. So the two strategies have advantages and drawbacks, and it's up to you. You can pick the software that works with the strategy that you want. In some cases, they use what's called the hybrid simulators, or the hybrid strategy. And in this strategy, the software picks part of the flow sheet to be solved as sequential, and part of the flow sheet to be solved as the equation based, or the simultaneous. And this depends on the understanding of or how the software sees the system, and how it understands that this part of the flow sheet can be solved easily with the sequential strategy, and let's do it like this, and then do the rest of the flow sheet the other way. And this is more in the commercial, not in the commercial software. It's mainly in the industrial software that are gonna be only available for those working in these companies, or whatever the place. So this is the point that I want to highlight in this chapter, which is section 1.3. Section 1.4 talks about the reasons for using the process simulators. You can take a look at it. It's kind of simple to understand, so I'm not gonna spend time working on this or discussing this because it's easy for you to read. And I think most of the people know the information that's put here, so there is no point of discussing it together. The last point I want to make in this video is what it's called the convergence analysis. I personally didn't read it thoroughly. I just passed by it, I skim read it, and I think it's not going to be of interest to most of the readers because it talks about the mathematical methods that are used to test the convergence if the solution is getting closer to the final solution or it's getting further, it's going to converge or diverge. So this is a lot of mathematics actually. If you check this, you'd see that there are some equations, and this is how the mathematics goes and how the solution goes. So I personally do not have a lot of interest in this, and I think most of the people do not do the same or have this interest. But it's there in case anybody is interested. You can find it. In this chapter is giving an introductory example. We're going to talk about this in few videos, and I'd like to keep it for them because there are some other points that we need to cover before we go to these examples. So until we finish this, we'll see you in the next video, and hopefully we'll reach this point soon. So I'll see you later. Goodbye.